This video continues us on the journey through chemical bonding. We're going to continue talking about Lewis diagrams, but now we're going to bring in double and triple bonds, which are sometimes known as multiple bonds. Remember that a Lewis diagram is nothing more than a representation of the molecular structure, and there are the 5 rules. The first one being fill out the NASB table. And if you've forgotten what NASB stands for, need to reach the noble gas configuration, available or valence electrons. Need minus available is the number of electrons that need to be shared. Take that number, divide by 2, and that's the number of bonds you need. Then you're going to figure out the central atom, and the central atom will never be hydrogen. Write down the central atom and place the other elements around it. Draw a single bond between the central atom and the outer atoms. Remember to subtract 2 electrons from the available column for each line that you draw. Take the remaining electrons from the available column and in pairs distribute them around the appropriate elements to complete noble gas configurations. So I want you to draw the Lewis diagram for this structure. I will show you the answer, and then I'll take you through it. Go. And this is the correct answer. We start with the NASB table, and here it is completed. We need 28. We have 20, so we need to share 8, so we need 4 bonds. Pick the central atom, never hydrogen, and silicon is less electronegative than chlorine, so it'll be the silicon. Then we're going to put the other atoms around the central atom, 1 in each quadrant in this case. Connect them all with single bonds. I have 4 single bonds, so I need to remove 8 from the available because I've used them. They're no longer available. Take the 12 remaining electrons and complete the octets. And I would go 2, 4, 6, 8, 10, 12. So now you can see that here I have 2, 4, 6, 8 valence electrons, noble gas configuration. 2, 4, 6, 8 valence electrons. 2, 4, 6, 8 valence electrons, and then 2 valence electrons, because that's all hydrogen needs for both of these. The octet rule is met. This is the valid structure. Now we want to draw the Lewis diagram for this structure. We want to follow the same rules. So we start with the NASB table, and there it is completed. Pick a central atom. If carbon is present, it's going to be the carbon. Put the other atoms around the central atom, so now you get something that looks like this. Add the single bonds, take away the 6 electrons, and now you have 6 electrons left to place. So you place them and you complete the octet. So we'll go 2, 4, 6, and you notice that this has a noble gas configuration. Hydrogen has a noble gas configuration, as does this one, but the carbon only has 2, 4, 6 electrons. It does not have a noble gas configuration. Now, even if I had taken 2 of these and put them here, then the carbon would have had the noble gas configuration, but the oxygen wouldn't. We don't have enough electrons. When you don't have enough electrons, then you need multiple bonds. Another way of knowing is, according to the NASB table, we need 4 bonds, but we only have 1, 2, 3. So something's got to give. When this happens, you're going to take these electrons and move them here. So you slide the outer pair to an inner area, and then because it's between elements, you can draw the straight line. And now you can see that you have 2, 4, 6, 8. Each line is 2 electrons, so that has noble gas configuration. 2, 4, 6, 8, noble gas configuration, and then both hydrogens have noble gas configuration. So when you don't have enough electrons, you got to start thinking about multiple bonds. Now, not in this case, but if you slide a pair in and you still can't meet the octet rule, then you repeat the slide. So here's one for you to try. This is hydrogen cyanide. I'd like you to draw the Lewis diagram for this. I'll then show you the answer. We'll go through it. Go. And that's what hydrogen cyanide looks like. How do we get it? We started with the NASB. There's the completed table. And once again, in this case, we need to share 8 and have 4 bonds. Carbon will be the central atom. So then we're going to put the other atoms around the central atom. I connect all with a single bond, take away the 4 electrons from the available, so I now have 6 left. Now I'm going to place the remaining electrons as pairs to complete the octets. And so I'll put 2 pairs around the carbon and 1 pair on the nitrogen. And we see that the carbon has 2, 4, 6, 8. The hydrogen has 2. And the nitrogen has 2, 4. That is not a noble gas configuration. So we're going to take this pair and slide it up here. When we do that, it looks like this. Hydrogen hasn't changed. Carbon still sees 8. And the nitrogen sees 2, 4, 6. That's still not an octet because octet means 8. We only have 6. So we're going to take these 2 electrons, slide them down here, and so now it looks like this. We haven't done anything to the hydrogen, so that is okay. The carbon still has 8 valence electrons, but now because the triple bond, and that's 6 electrons, and the pair out here is 8, so everybody's met the octet rule. Hydrogen never forms a multiple bond. It can only form one single bond, and then it's done. So to review, if you don't have enough available electrons so that every atom can achieve noble gas configuration, you're going to need multiple bonds. You start by sliding a pair of electrons from the outside to the inside to make a double bond. If that results in all elements having a noble gas configuration, then you're done. If you can't, you need to slide another pair and form a triple bond. Remember, there is no such thing as a quadruple bond. So that finishes the second part of the basics of Lewis diagram. In the next video, we're going to tackle one more basic Lewis diagram, and those are ions.